Okay, so here's what we're doing today, guys. Okay, we're going to start working on our energy conversion project. I'm just going to try and make this little tiny bit bigger. Yeah, that's a little tiny bit bigger. And it still fits, so that's perfect. Okay, so in this project, what we're doing is we are looking to research some examples of places where energy conversions occur. Okay, why they're important. Okay, for our society, what kind of energy conversions they are. Is it like heat to mechanical energy? Is it heat to mechanical energy to electricity? Is it, like just straight kinetic energy to electricity? Is it, like looking at how many conversions of energy there would be kind of along the chain from the initial type of energy to the final type of energy, looking at whether that's efficient or not, whether that's a good use of energy, okay, stuff like that. So we're looking, there's a bit of a societal component, as there always is when we do a research project, but there's also obviously the physics standpoint of that as well, okay, where we're talking about these are the conversions of energy. Here's where energy can be lost. You can talk about, law of conservation of energy and all that kind of stuff that we've talked about in class. We want to incorporate all of that into our project when we're talking about it. Okay, so in this project, you are to examine a process that converts energy from one form to another and how this is accomplished. Okay, topic choices could be the generation of electricity from coal, which we do a lot of in Alberta. Okay, one example would be the Sheerness coal plant, which they've actually shut down, I think, recently. So they, any place where they generate electricity using coal. Okay, electrical generation via wind turbines, like they do in Pincher Creek. There's also some out by Carbon. Okay, there's a fair amount of wind generation in Alberta. I think it represents now about 6% of our electrical grid in Alberta, somewhere in there. Okay, generation of electricity in a hydroelectric dam. Okay, so that could be examples of that could be like Hoover Dam or Grand Coulee Dam in Washington, places like that are massive hydroelectric projects. Okay, generation of electricity in a nuclear power plant. Okay, so you could look at CANDU reactors. Those are the Canadian heavy water nuclear reactors that we design and build here in Canada. Okay, or you could look at other types of nuclear power plants. Okay, if you're looking at different types, like ones that might be in the States, like 3 Mile Island, or something like that. Or use of solar cells, okay, and their conversion of solar energy to electricity. Obviously, we have the big solar enclave in Drake Landing here, okay, that you could use as an example as well. Okay, kind of advantages and disadvantages to solar and how well that works. Okay, and then fuel cells, which are a new and emerging technology for storing chemical energy for use in making electrical energy. Okay, most of those are hydrogen fuel cells, okay, that you could also look at if you were interested in that. Okay, so you got a few different choices there for which conversions of energy you want to research. Okay, all right, thanks, Nixon. Okay, so our project outline. So in your project, okay, you need to do this. Okay, you need to report on what the initial source of energy for power generation in your topic is. Okay, and what type of energy it is. So is it chemical? Is it mechanical? So if you're looking at coal, coal obviously is your initial fuel source. Coal is a form of chemical energy. Okay, so you're going to have to talk about how, how is energy stored in that? Okay, how do we convert it, etc. Okay, you'll also need to explain the principles used in the conversion of one form of energy to another. So how do they release the energy in coal? How do they capture and harness the energy in coal? How do they convert and turn it into electricity? Okay, a detailed explanation of the structure of the plant or device in your topic is also necessary. Okay, what are the major parts? So basically you have to explain to me, how does a coal-fired electrical plant work? Okay, what goes on in there? Okay, what are some of the major parts? Okay, stuff like that. Okay, what purpose do they serve? What types of materials are used in their construction? Okay, are there special materials that are needed to build these things? Are wind turbines made out of a special material? Okay, solar panels, what kind of materials are they made out of, etc. Okay, now the next part is the societal part, so an examination of the societal effects should be included as well. Okay, is this a source of energy that is used a lot, or is it an emerging technology? What are its future usage and applications looking like? Like, for example, coal is being phased out in a lot of places, okay? Whereas, wind generation and solar generation and stuff like that are trying to be introduced and trying to be made more mainstream and more effective, okay? Will it continue to be available? Is it a fuel source that's, got a lot of reserve? Okay, if we're talking about, coal, obviously there is a lot. Okay, where is it located? How easy is it to get to? Okay, stuff like that. How do people feel about this source of energy? Is it safe? I mean, if you're talking about nuclear power, there's an argument to say maybe not so safe. If you live in the Ukraine, okay, you might not feel so good about it. Okay, have there ever been any cases where it became a danger to those who operate and depend on it? Like in the Ukraine, there was that thing that happened there. Okay, what's the return of this device or power plant? Okay, compared to its price for construction, does it produce a lot of usable power? Okay, that's what we mean by what's the return on this device or plant? Okay, how much how long does it last for? Does it produce a lot of electricity while it's useful? And then eventually does it have to be shut down and just dismantled? Okay, nuclear power plants do kind of have a shelf life. Okay, they last for a certain amount of time and then they have to go. Solar panels, same thing. They're good for a while, but eventually they wear out. Okay, so you got to look at that. Okay, environmental effects. Okay, what are the environmental effects of this method of power generation? Is there a lot of pollution? What are the waste products? What's done with the waste products? Okay, is the fuel easy to come by, or does the acquisition of fuel involve a lot of environmental impact? Okay, is building the plant or device of this kind involve a lot of construction and environmental disturbance? Okay, what's the efficiency of this type of energy conversion? That's probably a big one. If you're looking at societal effects, okay, look at efficiency. All right, do we get a lot of energy out of this, or do we have to use a lot of it because it's so inefficient? Okay, stuff like that. But also, again, look at your waste products. Okay, what's done with them? How do you dispose of them? Right, things of that nature. Okay, visual aids. Your project must contain pictures and/or diagrams, schematics of a power plant. If you're talking about that, would be really useful. Okay. Sorry, it doesn't stay on the PDF when I move it. Okay, and then remember when you're citing your references, and we've talked about this a bunch of times now, and I always use the same example, okay, and it's this one right here. Remember that when you're citing a website, it needs to look like this does, okay? Your references cited must be in this format. This is now the third one of these that we've done, okay? And this is where people continually lose marks, is because they just write down www.ididn'tlistentomrcoderre.com, okay, for their references, and that's not good enough. It needs to have the author's name, the date the article was posted, the name of the article, the name of the website, then the URL, and then the date you access it. Make sure it has all of that information when you cite it, please. Okay, you should have at least 5 references. That's where I get the 5 marks from. Okay, you got 5 references, they're all in the right format, 5 marks. Okay, you got 3 references, they're all in the right format, 3 marks. You got 5 references, all in the wrong format, no marks. Okay, make sure it's in the right format. Okay, and then planning. This is the other place where people have been losing marks needlessly each and every time we've done one of these. Okay, the planning, do that today. Get it out of the way. You only have to do 2 things for the planning. Okay, a thought web or outline, whichever makes more sense to you. Okay, so a thought web, draw all the little bubbles and contain your ideas and how they're going to be related. Or an outline that says, paragraph 1, introduction. Paragraph 2, talk about how coal is acquired. Paragraph 3, talk about why coal stores energy, blah, 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 just whatever, an outline, okay? So one or the other of those and a timeline. When are you working on it? You can start with today. Okay? You can say December 15th, started research. Okay, whatever it is, right? Just record and set your timeline up. Those are the only 2 things you need for 5 marks. Okay, 5 marks, outline or thought web, and your timeline. That's it. Okay, make sure you have those 2 things for 5 easy marks. Okay, okay, so the scope, okay, this is the same as your plant research project, okay, about 1,200 to 1,600 words, so about the same length as that. Okay, don't worry about the PowerPoint presentation part, I forgot to take that off. Haven't had time to do this one for a while, so it's kind of an old version. You're not going to have to worry about video essays or anything like that. Just keep the word count in mind. Even if you do a Google slide presentation, make sure you copy all your text into the Google Doc so that you can get a word count and you know how many words you have. Okay. All right, so the 5 categories, same 5. You always get 5 marks for planning. So timeline, and then thought, Weber, outline. Right? Your analysis and interpretation, that's all the stuff that you write in there telling me about energy conversions, efficiency, societal effect, all of that, that's 5 marks. Communication, similar to that. Okay, how well do you tell me those ideas? Okay, does your project flow, or is it just a bulleted list of ideas that aren't connected and it's just one bulleted list after another? Okay, make sure you tie your ideas together. You need, what is it called, segues, okay, from one thing to another, right, so that the project flows. Okay. Also in communication, right, when you're writing it, do I understand what you're trying to say? That's also an important part of communication. Okay. Research and investigation, we talked about that. Minimum 5 references in the proper format for 5 marks for that. And then lastly, okay, overall, which is your format, creativity, or quality. Okay, if I open up your Google Doc and it looks like it's bleeding because it's got so many spelling mistakes, okay, that haven't been checked, then that's not going to impress me much. You know, if it's full of grammatical errors, so much so that I'm wondering if I'm reading a different language, okay, that's also not good. Make sure that your project is free of those things. Run the grammar checker, run the spell checker, okay, so that I'm not stumbling over stuff. Okay, again, make sure it flows, make sure it's tied together, find ways to incorporate diagrams and make them fit. Don't just have kind of random diagrams that don't really fit with what you're writing. Okay, find ways to wrap the text around them. Just make it neat and presentable for when I'm looking at it. Okay, that's where your overall comes in. Alrighty. Okay, questions on that? Okay. I would appreciate it, and this is like not so much a request as it is please stay in the meeting, okay? Stay in the live stream. If you have questions, just ask, and I will talk about them with you, or I'll answer them for you. And then you've got the rest of class today to work on this, okay? You'll have all of tomorrow's class to work on this, and probably some of Thursday's class. I'm kind of leaning towards having some of Thursday's class to work on this as well, right? So there's going to be lots of class time to get this project done. Just make sure you're using it effectively, okay? So stay in the live stream. If you got questions, I'll answer them, or if something else comes up in my mind that I need to talk to you about, then I'll talk to you about it just in case something else comes up, okay? Questions from you guys? All right, perfect. Have at her.